Good day to the great panelists, Dr. Mazarafi and Dr. Nodiana. So, first of all, I would like to thank you for everyone for joining my presentation today. So, without further delay, I would like to introduce myself. I'm Tharnisha A. Sithananthan and my entry number is CE190099. So, I'm one of the students under the supervision of Dr. Afur Razi bin Abu Bakar. Today, I'm going to present the progress regarding the FYP1 entitled Enhanced Switching Control for Fast Response Rated Single Phase Inverter using FPGA. Let me give an overview of the presentation going today. So now let me give an overview of how the presentation is going to be today. First of all, I would like to give a brief introduction regarding the project and also literature review. After that, we're going to focus on the methodology, expert results, and also conclusion. So what we have to know is about the project is that this is a grid synchronization project where the generation of electricity is the main focus of the topic, and also the generated power is particularly is renewable energy that must be regulated to match the electric alternating current. So, what we can see here is that the integration of the renewable energy with the electric grid still have to be paid attention, as the integration are not stable due to its intermittent nature factor. Thus, the system needs an grid synchronization and also improve power quality that can be accomplished by the usage of power condition devices such as single phase MOSFETs that can be used with a single phase voltage inverter. Apart from that, fast response is also required during the grid synchronization in order to detect sudden changes in the grid, especially during the unbalanced load to produce a smoother output. So, this project will stimulate the performance parameter of the synchronous inverter was to establish the design and analyze for the fast switching of the single phase full wave inverter for a faster response by utilizing FPGA. Also, we're going to analyze the performance of the proposed fast switching method. Next, let's look into the problem statement. A suitable energy storage is needed to increase the penetration of the renewable energy sources. So, in this context, there is a growing concern over the use of energy storage to manage the demand while overcoming the erratic nature of renewable energy sources. So, the right power condition devices are necessary in order to complete the grid synchronization of energy storage. Therefore, techniques involved in this project are ZCD and also PLL. ZCD will be used for measuring the phase and frequency of a signal at the zero crossing point, while PLL is a feedback circuit that automatically aligns the phase of a locally generated signal with the phase of an input signal technique. While ZCD technique has been used traditionally in order for the synchronization process, at where power converter and grid that have been proposed many ways that can improve the performance of the system, and also we can reduce the noise of the system as well. So PLL is a phase detector technique that synchronizes the signal with the reference of phase and frequency. Next, let's look in the objective of the project. The main objectives of the project are to develop single phase full wave inverter circuitry for grid synchronization using MATLAB and Simulink. Next is to design and enhance fast response switching based on ZCD and PLL for single phase full wave inverter using VHDL. After that, our final objective is to analyze the performance of the proposed fast switching method in terms of system stability, response time, THT, and also efficiency. Next, let's look into the scope of this project. Our scope of this project is to implementing VHDL to the FPGA board using Cortex 2 version 9.2, utilization of MATLAB simulating software to simulate the performance parameter, and also finally, proposed project will be developed by using VHDL coding and also software simulation with the appropriate hardware and software specifications. Next, let's look into the literature review. So basically, we took a literature review by analyzing around 7 articles. So, based on the literature reviews, out of 4 research papers have been uh, analyzed that using three-phase system, while remaining articles using single-phase system. So, in this our project, we are using single-phase system as well. So, one of the significant difference from the previous studies with this project is the usage of FPGA for controlling the full bridge inverter with PWM. Okay, now I'm going to present on the methodology part. So for the hardware, we are using FPGA board of Altera DE270 model with an input voltage of 24 VDC, and we'll be obtaining an output voltage of 240 VAC And we are simulating the project with frequency of 50 Hz. So the switching devices involved in this project are MOSFETs, the filter will be LC filter or also low pass filter, and also a step up transformer. For the completion of the project, we are using two softwares, which is the MATLAB Simulink and also Quartus 2 version 9.1. Next, this is the block diagram of our project. So firstly, we have input source that we fed into the full bridge inverter, and then we will be using LC filter to smoothen the output, and also we using step up transformer to step up the 24 VDC to 240 VAC. And also we will be using phase lock loop and ZC technique for the grid signature process that will be implemented into FPGA. Then we'll be having PWM generator, circuit driver, and also full bridge inverter. So this process will give an output of grid synchronized signal. So in this project, we are focusing on three main components, which is single phase full bridge inverter, LC filter, and the step up transformer. So the blue box represents the specifications of a single phase full bridge inverter, which is DC voltage of 24 V, switching diode, MOSFET, and resistor of 1 ohm. Next, for the LC filter, we are using 1 ohm resistor, 22 millihenry and inductor, 120 microfarad of capacitor, and also is a low pass filter. Next, for the transformer, we are using values in VRMS, which is for the primary winding is 16.97 VRMS and secondary winding of 169.70 VRMS. So apart from that, we also are focusing on the switching strategies. So the green color box represents the switching strategies for switch 1 and switch 2, also Q1 and Q2, while the blue box represents the switching strategies of Q3 and Q4. So FYP1, I have successfully implemented the system of single phase full bridge inverter that connected with LC filter setup transformer, and we are obtaining the results. So this is DC voltage source of 20 V DC will be connected with 4 MOSFETs, and we have a resistor load over here and also a healthy filter setup transformer, and also this is also script to uh, view the output. Next, by the simulated results, we obtained a comparative analysis between amplitude modulation index and also THD. So what we can see here is that the higher the amplitude modulation index, the lower the THD will be. Next, by using the switching strategies I have explained earlier, the switching strategies we obtained a result by doing a coding using Quartus 2 software, and the results are visible by the simulation and also by uploading the coding using oscilloscope. So this is the results for Q1, Q2, and Q3, Q4. So for FYP1, we expected to obtain a result of developing a circuit using simulation software that consists of single phase full wave inverter and also that involves PLL and ZC control technique using FPGA, and able to interpret the technical issues that occurred in the process of circuit development, and finally is to able to develop a complex system that connects with the utility grid supply. Next, for the conclusion, I would like to uh, give an overlook of our next FYP2 project. For the FYP2 project, I'll be going to complete the task of developing a full signal simulation, enhance the output of the signal, and also to test the simulation in hardware of the circuit and also the performance parameter. Also, we are going to accomplish the objective of the project. So, for the completion of the project and also the completion of the report writing, we are referring for several references such as journals, articles, proceedings, books and thesis, and also internet sources. So that's all from me. Thank you.